This lesson is over prime factorization, the second part. So are these the factors of 48? If not, find a missing factor and write the factor using exponents. So according to this, let me get my pens. Well, let's see. 3 times 2 is 6, and 2 times 2 is 4. 6 times 4 is 24. Wait, I'm missing something here. 48 is 6 times 8. So 2 times 2 is 4, so I'm missing a 2 right here. So how would I write this using exponent? 2 to the 4th power times 3. And this is what it should be. So let's talk about other stuff while we're here in this thing. So first I want to talk about is what are the different factors of 48? So I could say 2 times, 2 times, this is 2 times 2 times 2 times 3 is 24. 2 times 24 makes 48. So I'm going to write that down. 2 times 24 could be 48. I can also say, if I move this here, 4 times 2 times 2 is 4, 4 times 3 is 12. 4 times 12 makes 48. I can also say 2 times 2 times 2 is 8. 8 times 6 is 48. And I can lastly say 2 times 2 times 2 times 2 is 16 times 3. I can also say what else makes 48? 2 to the 4th power times 3 makes 48. I can say 2 cubed times 6 makes 48. So there's so many different ways I can write the factors of 48. So let's watch this video. Let me load up the volume. And let's press play. So this is a movie called Contact. Her name is Dr. Airway, and she discovered different types of numbers. She recorded 2, 3, 5, and 7. How do you know any relationship between these numbers? What can you tell me about these numbers? And can you continue the pattern up to the 10th term? And what are these numbers called? I always have kids who say, oh, they're odd numbers, but 2 is not odd. So what can you tell me about these numbers? Anything. Well, 2 is 2 times 1. 3 is 3 times 1. 5 times 1. 7 times 1. Oh, these are prime numbers. So the next number is not 9 times 1, because that's 3 times 3. It's 11. 11 times 1. What would be the next prime number? 13. 13 times 1. What would be the next prime number? 14 is no. 15. 5 times 3, no. 16. 17 times 1. 18, 19, 19 times 1. 20 made up multiple factors. 21 is 3 times 7, 21, 22, 23, 24, that's 4 times 6, 25 is 5 times 5, 26, 2 times 13, 27, 9 times 3, 28, 2 times 14, oh, 29. So these are, to be honest, you really just need to know the first 5 prime numbers. 2, 3, 5, 7, 11. Let's continue watching a second video. Let me press play. So, does anybody have you seen this movie? This movie is called Hidden Figures. Great movie. Her name is Catherine. I forgot what her last name is, but she, as you can tell, she was very bright. She was able to go from an elementary girl into a to a high school preparatory in record time, and she helped NASA reach space. And you could tell at a young age, as she was walking, she was counting her steps with prime numbers. And so why are prime numbers important? Prime numbers are used in a lot of things like code breaking, in computer codes, and so on. So do you know the first five prime numbers? We talked about, do you remember it? You may need to look at the previous video for it. 2 is the first prime number. 3 is the next one. 5, 7. A lot of kids want to say 9, but it's 11. So prime factorization is finding which prime numbers, like 2, 3, 5, 7, 11, multiplied together to make the original number. To find a prime factorization, it's helpful to be using something called a factor tree. So 60 can be broken down by 6 times 10. Maybe you don't like 6 times 10, you rather break it down the factors of 2 times 30. Then 6 can be broken down in 2 times 3, 10 is 2 times 5. Notice that there are 2 2's, 2 square, 3 times 5. So another way you could break it down is by 2 times 30. 30 is broken down by 2 times 15. 15 is broken down by 3 times 5. 2, 2, 3, 5. Notice how I circle in red the prime factors, so you can tell which numbers are the prime versus the composite. So generate an equivalent expression using prime factorization. So what factors make 135? Well, it's not even, so I know it can't be divided by 2. But I see a 5 in the ones place, so I believe 135 can be divided by 5. It's divisible by 5. 5, 5, 10, 15, 20, 25. 5 goes in 1, 0 times. 5 goes in 13, 2 times. 3, bring down to 5. 5 goes in 35, whoops, 7 times. So it's 5 times 27. So circle the 5. You know, I should be using a different pen color. Let me go back to black. 5 is prime, because remember the prime numbers are 2, 3, 5, 7, 11. 27 can be broken down in 9 times 3. 9, the factors of 9 are 3 times 3. So let's circle the prime factors. 3, 3, 3. So how would I write out these factors using exponent? 3 to the cube times 5. Next one, the prime factorization of the number 144 is 2 to the a power times 3 to the b power. What is the sum of a plus b? So 144. What are the factors of 144? I can say 2 times something, maybe 12 times something. I'm going to do 12 times something. 12 times 12 makes 144. But can 12 be broken down? Well, they're both the same, so we're just going to copy it like a mirror effect. 12 can be broken down 4 times 3. 4 times 3. Can 4 be broken down into factors? Yes, 2 times 2. 2 times 2. Can 3 be broken down? I don't think so. So in red, I'm going to circle in red. 2, 2, 3 primes. 2, 2, 3 prime. So 2 to the 4th power times 3 squared. So if I add up these exponents, 4 and 2, it adds up to 4 plus 2 equal 6. So our last part of the lesson is, given the exponent, can you find the original number? What is 5 square? 5 square is 5 times 5. 3 square is 3 times 3. How did I get that? The number is 5. That's the factor. You are going to write it twice. 3 is the factor. You write it twice. So 5 times 5 is 25. 3 times 3 is 9. And what is 25 times 9? 9 times 5 is 45. Carry the 4. 9 times 2 is 18 plus 4, 225. What about the last one? 2 cubed times 7 squared. 2 is a factor. It's repeated 3 times. 7 is a factor. It's repeated twice. So what's 2 times 2? 4 times 2 is 8. 7 times 7 is 49. So what is 49 times 8? 8 times 9 is 72. Carry the 7. 8 times 4 is 32 plus 7 is 39. 392. So the last thing you can do is you're going to be Christmas is coming, so we will be playing rocking the thing. So you're going to be given one of these numbers, and you're going to be making a Christmas tree. As you can tell, the ornaments of the tree are the prime factors. So you can write out the prime factors and the prime factorization using exponents. And that is our lesson about prime factorization. Smart quarter.